Exercise 1203 is about the mean or expected value. So we have this notation E of x, which is the expected value. It's a measure of central tendency or an average. Now you might remember that mean, median, mode, they're all measures of central tendency. This one's really like the mean. So mu, the Greek letter mu, that stands for the population mean, whereas x bar, which is x with a line above it, is the sample mean. So if you're just sampling some of your population to estimate your mean, x bar is your mean of your sample, mu is the mean of the entire population. So the larger your sample, the better x bar will approximate mu. So here's an example. We've got some data. Our x values are 1, 2, 3, and 4. The number 1 comes up 5 times, number 2 comes up 8 times, number 3 comes up 3 times, and number 4 comes up 4 times. So a total of 20 trials in this experiment. We've got an f times x column here, so 1 times 5 is 5. So that number gives us the sum of all of those ones. We have 5 ones, they add to 5. We have 8 twos, so if you add up all those twos, they add to 16. We have 3 threes, if you add up all those threes, they'll add to 9. And we have 4 fours, so if you add up all those fours, they'll add to 16. And if you add up all of your scores, they'll add to 46. And you have 20 scores. So back in year 8, you learned how to find the mean using this formula here, where you've got the sum of the fx column, the sum of all your scores, divided by the sum of the f column, the frequency column, which is how many scores you have. So all your scores add to 46, and there are 20 scores. Now to simplify that, I can divide by 2, I get 23 on 10, and 23 on 10 is the same as 2.3. So our mean is 2.3. Now, in our new method, we eliminate the need for the fx column, and if we've just got a standard probability distribution, we can find the mean straight away. So in order to do this, we need to find the probability of each score. So we're looking at the relative frequency column, and we know that 1 occurred 5 times out of 20 times. The 2 occurred 8 times out of 20. The 3 occurred 3 times out of 20. And the 4 occurred 4 times out of 20. If you add all those up, they definitely add to 1. So those are the relative frequencies of the experiment, or the probability, the experimental probability of each one happening. Now to find the mean, what we do is we add up, so sum of the x's multiplied by the probability of the x's. So we're multiplying the x by the relative frequency or the probability column, and we get the same answer. So we get 1 times 5 on 20 plus 2 times 8 on 20 plus 3 times 3 on 20 plus 4 times 4 on 20, and that equals 2.3, the same answer as above. So in example 2, we're going to find the expected value of this distribution. You'll get a lot of these questions. They're pretty straightforward. It's all the same kind of thing. So the expected value is 2 times 0.5 plus 3 times 0.2 plus 4 times 0.15 plus 5 times 0.1 plus 6 times 0.05. Now, if you look at this data, it's what we call positively skewed data. So there's a lot down here. There's a higher probability down here with a lower probability as you go this way. So it's positively skewed. So if you were to graph it, you'd really have that shape. We'd expect the mean to be way back further towards the left. And sure enough, if you add all of those up, the final answer is 3. The mean of that data is 3, which is right down this end of the data. In this question, we've got a game of chance where 2 coins are tossed. A player wins $3 for 2 heads, $1 for 2 tails, and nothing for a head and a tail. Find the expected value of this game. So if we just collate that data, 2 heads we said is $3, 2 tails is $1, and a head and a tail is $0. So the problem is here that saying heads, 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 tails, 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 that's not numerical, that's categorical in a way. But what we really want to look at is the probability of each of those things happening. So the probability of winning $3, that's a quarter. You've got to remember that head, tail, tail, head, there's 2 ways you can get a head and a tail. So winning no money at all happens half the time, 2 out of 4 of the time. And tail, tail, that's also a quarter. So that's the data we really want to look at to calculate our expected value. So we have 3 times a quarter plus 0 times 1/2 plus 1 times 1/4. So our expected value here is 4 quarters, which is 1 whole. So on average, over time, we'd expect to win $1 each time we play. So if the game costs $2 to play, would a player expect to win in the long term? No, absolutely not. They play $2 each game. Sometimes they might win $3, sometimes they might win $1. Sometimes they might win nothing. But overall, they're going to average out on $1 each play, but they're paying $2 each play. So they're not going to win in the long term. In question 4, we have to find the values of x and y given that our expected value equals 5.45. So we do this with simultaneous equations. There are 2 things we know. One is that if we go 3x plus x plus 2y plus 0.4 plus 0.2, that's going to equal 1. So if I just simplify that a little bit, I've got 4x plus 2y, 0.4 and 0.2 make 0.6. I'm going to subtract those from each side, so that equals 0.4. Let's halve those. So 2x plus y is equal to 0.2. So that's our first piece of information. Now our second piece is this expected value that we were told. We know that 3 times 3x plus 4 times x plus 5 times 2y plus 6 times 0.4 plus 7 times 0.2, our expected value, is equal to 5.45. So let's work that out. So we've got a 9x and a 4x, that's 13x. We've got 5 lots of 2y, so that's 10y. We've got 6 lots of 0.4, that's a 2.4. 4 6s are 24. 2 sevens are 14, so 1.4 equals 5.45. 2.4 and 1.4 are 3.8. So 13x plus 10y equals, we've got 5.45 minus that 3.8. So let's borrow 1 there. 1.65. Now I might use the substitution method. So from this line, I'm going to say y equals 0.2 minus 2x. So 13x plus 10 times 0.2 minus 2x equals 1.65. 13x plus 2 minus 20x equals 1.65. Negative 7x equals negative 0.35. If I divide by negative 7, my x is equal to 0.05. Now, I need to also find the value of y. So I'm going to go back to this equation here, where 2x plus y equals 0.2. So 2 times 0.05 plus y equals 0.2, so that's 0.1 plus y equals 0.2, minus 0.1 from each side, y is equal to 0.1. So x is 0.05 and y is 0.1. Simultaneous equations, I always like to put my answer in a little box like that. Now let's have a look at this question. The chance of winning the game is 0.4. Find the expected number of wins if a person competes twice. So let's start by having a little look at a tree diagram. So they could win or lose on the first time, 0.4 that they win, so 0.6 that they lose. On the second one, now we're expecting here that it's still a 0.4 chance because we weren't told otherwise, so 0.6 that they lose, and the same down here, win or lose is 0.4 and 0.6. So win-win, if I multiply across, that is 0.16. 0.4 times 0.6 is 0.24, 0.24 again there, and 0.6 times 0.6 is 0.36. So we need to draw ourselves up a little table, and we'll say our x value, we have 0 wins, 1 win, or 2 wins, and our probability for that. So 0 wins is that we lose twice, that's our 0.36. 2 wins is that we win twice, so that's our 0.16 there. And in the middle, 1 win is win, lose, or lose, win, that is 0.48. So our expected number of wins, or the expected value, is 0 times 0.36 plus 1 times 0.48 plus 2 times 0.16. And that's equal to 0.8. Now that makes sense. There's a bigger chance of 0 wins than there is of 2 wins. So the final answer will be slightly further to the left than 1. So 0.8 makes sense as the expected number of wins from competing twice. So a little less than once each time they compete. So if they play twice, on average, you'd expect them to win 0.8 games. So keep in mind, of course, 0.8 out of 2 is the same as 0.4 out of 1. So this expected value of 0.4 is the same thing, really. Now, there are instructions on page 677 on how to find the expected value with your calculator. So I'm going to enter the data from example 2 into my calculator to find the expected value. So the first thing we want to do is hit this button for mode and 3 for stat mode. Now on this one you can just press 1 var. Now I have my frequency column turned on. If you don't have that turned on, to turn it on you just go shift mode and then you need to press the down arrow and then have 4 for stat, frequency on 1. You can leave it on all the time, there's no problem with doing that. I would suggest you do that, but practice how to put it in. So our x values were 2, 3, 4, 5, 6. Just press equals after each one. Once you've entered those in, if you arrow to the right and then go down 1, it'll take you back to the top. You can press up a bunch of times if you want to. Now it does enter 1 for each frequency, but we need to fix that. So 0.5 was the first one, 0.2 was the second one, 0.15 was the third one, 0.1 and 0.05. Once those are all in, you just press the AC button. Don't worry, it has not deleted your data, it remembers your data. You just press AC to get back to the main screen. Now to calculate the mean, you press shift and then 1. You see just above 1 it's got stat in yellow. So pressing shift gets to that yellow. and you see this screen here. Now different calculators will have some different things here, but to find the mean, it's under var number 4. So you can see here n is the number of scores in your data set. X bar is the mean. That's what we're looking for. That's the expected value. Number 3, that's the population standard deviation. And number 4 is the sample standard deviation. We are going to learn more about those in the next exercise. For now, we want the expected value, or the mean, which is number 2. So I'm going to press 2, and then I'm going to press equals. And that's that answer we got, 3.